Hi, it's your guy Olumide, and today we're gonna be solving another one of the most commonly asked data structure and algorithm problem in tech interviews at top tech companies, including Google, Amazon, Meta, Netflix, and Microsoft. So let's get into it. Alright. The problem statement says a palindrome is a sequence of characters that read the same forward and backward. What that simply means is that a palindrome is actually a string, a sequence of character. But now what differentiates it and distinguishes it from other sequences of characters is that it reads the same forward and backward. Meaning that, consider this string that's given in the example. We have a dog, a panic, a pagoda. Now this A, you will see that it reads the same forward and backward. So neglecting alphanumeric and non-alphanumeric characters. Don't forget, in the question statement it says given the string, determine if it's a palindrome after removing all non-alphanumeric characters. So we are not going to be considering non-alphanumeric characters like dots, like empty space, like this exclamation mark. We are just going to be considering alphanumeric, which means letters and numbers. So if you should consider that now, you will see that this particular sentence, this particular string reads the same forward and backward. This is A here and this is A here. So this is D next. We actually neglect the space because it's non-alphanumeric. So this is D here, and right here this is O, this is O, this is G, this is G. So this is A, this is A, this is P, this is P. So, and that's how it goes on and on and on. And so if it is a valid palindrome, that is for each character it reads the same forward and backward, then we're gonna be sending through to the output. But if it doesn't work out like that, probably the string does not read the same forward and backward, just like in this case where this is A and this is 3, so it doesn't read the same. So once one condition is broken, once one particular character does not read the same at the front and at the back, you don't need to consider the rest. It is not a valid palindrome and you therefore return false. So let's go into the logic behind this now, and it's gonna be interesting. An important observation about palindromes is that they read the same forward and backward. Look at this example string here. We have BYTE ETYB. You will see that it reads the same backward as BYTE ETYB. So that's what we call a valid palindrome. They read the same forward and backward. But this palindrome string is of even length because the string have length of 8 characters. If you count the characters now, they are 8. So you understand. Let's consider and take a look at a palindrome string of odd length, such as this Riska. We can see that Riska have an odd length. This is length 1, 2, 3, 4, 5, 6, 7. So it has a length of 7 characters, and it is still a valid palindrome. Why? Because it reads the same left and right. But one thing that distinguishes the even palindrome from odd palindrome is that there's always one character that is left. You understand? But because this character does not have a pair, it does not have a corresponding pair in the array, and everyone that comes before it is a valid palindrome. Why? Because you see this C that comes before it already exists here as well, and this A that comes before the C also have its pair here, and this R similarly have its pair here. Definitely we can conclude that it is a valid palindrome because this one is actually shared between the left and the right. So it is a valid palindrome as well. So just as we can have even valid palindrome amongst even characters of a string, we can also have valid palindrome among strings of old length or old characters. So if you observe well enough, you will notice that palindrome also provide an ideal scenario for using two pointers, a left and a right pointer, in such a way that if we place the left pointer at the extreme left of the string and a right pointer at the extreme right of the string, we can use it to check if they are if it is really a valid palindrome, if the string is a valid palindrome, because the left pointer will be equals to the right pointer, and it means that okay, that particular character represent a valid palindrome, and then we can shift our left pointer again to the right, and our left pointer to the right, and our right pointer again also to the left, and perform another check again if they are equal. If they are equal again, we shift our left pointer again to the right and shift our right pointer again to the left to check if this corresponding string are equal. So we see that it provides a valid scenario to apply two pointer techniques, and two pointer techniques will really solve this problem. So if you look at our previous examples, like we have here in the race car and in the bytes that reverse back, you will see that you will notice that we ignore non-alphanumeric character. So you see that in explaining in these previous examples, we ignore non-alphanumeric character. We only deal with string and numbers. So for now, we are going to be ignoring alphanumeric character, and we can summarize our logic as follows. That is, for string that does not contain alphanumeric characters, this is the logic for checking if they are valid palindrome or not. If the alphanumeric character at left and right are the same, so at the left and the right pointer, just like we can see in this example string, if the alphanumeric character at the left pointer and the right pointer are the same, then we move the pointers inward to process the next pair of characters. Don't forget that for a string to be a valid palindrome, all its characters need to be the same, like in reverse, like we explained in the logic, not just one. So when we place our left and right pointer at the extreme, we try to check if the characters there are the same. If they are, then we shift our left pointer by one, and we shift our right pointer also to the left by one, and that's what we describe here. But if the string does not contain a valid palindrome, we return false. And what this means is that if at a point left and right, if the character at those pointers does not correspond, just like in this example where we have character A and here we have character 3, although A and 3 are both alphanumeric character, but because they are not the same, A is not equal to 3, therefore we are going to break out of the loop. You don't need to search any further, because once the left pointer and right pointer does not correlate at any point, we break. It is not a valid palindrome. So if we can successfully compare all character pair without returning false, that is, without reaching a particular point whereby the left pointer and the right pointer does not point to the same character, you understand, or does not have same character, just like in this point whereby left is pointing to A and right is pointing to 3. So at that point we are going to return and break out of the loop. But if we can successfully compare all character without returning false, definitely we are going to return true. Now, how do we process non-alphanumeric characters? For non-alphanumeric characters now, we are going to increment left. If left fall on a non-alphanumeric character, just like in this example, if it fall on plus or empty space, we are going to keep incrementing it until it points to a alphanumeric character, meaning that at the point whereby it points to plus, we are going to just increment and keep incrementing until it points to a alphanumeric character like 2. So, and also we are going to keep decrementing right until it points to a alphanumeric character. So if right fall on let's say this slash now, we are gonna keep incrementing it even beyond this space until it falls onto a alphanumeric character. So now, with this in mind, let's check if this string below is a valid palindrome. So we have this string here. We have this string a plus 2c slash 2a. So now the first thing is that we place them as the two extreme. We place the 2 pointer at the 2 extreme. Now we check if they are the same. Right here, left pointer is pointing at a, right pointer is pointing at a. So left, s of left is s of right, provided s is the string. So we therefore will increase our left by 1 and reduce our right by 1, moving them inwards to try out the next alphanumeric character. Now we shifted it inward. So left is now pointing at index 1, right is now pointing at index 6. But we say that left is actually pointing at a non-alphanumeric character plus. So else of left is not alphanumeric, so we increase our left by 1. Right now at this point, we shifted our left by 1 to the right and is now pointing at 2, which is a alphanumeric character. So right is still pointing at 2, and now s of left is equals to f of right. So what we do is that we shift our left again to the right by 1 and our left to the left and our right to the left by 1. So to check other characters, to process other characters. Right now we shifted our left pointer by 1 to the right and our right pointer by 1 to the left, but now our right pointer is pointing at this non-alphanumeric character, even though our left pointer is pointing at a alphanumeric character. So what we do is that we keep on, we reduce our right pointer by 1 to the left. At this point, we shifted our right pointer by 1 to the left, and now it is pointing at C, which is the same character that the left pointer is pointing at. So we see that at this point they are valid. The string is a valid palindrome because all the alphabet of all the alphanumeric character. We see that at this point the string is a valid palindrome because up to the point that the left and the right pointer meet, which signify the end of the loop, we realize that we do not return false. So meaning that every string and every character correlates in reverse, and therefore we are going to break out of the loop and return true, that here this is a valid palindrome. In this previous example, we consider a string of odd length, which is length 7. Now let's consider a string of even length, which is length 4 here, ABBA. We see that we follow through the same process, and we check at the two extremes and it is equal, so we move our pointer inward on both cases, left and right, and then we check at this point and they are equal, so we move them inward again at both cases. But now we see that the left, at this point, the left pointer is now pointing at a higher index than the right pointer. Why? Because there is a switch. Left increased by 1, right decreased by 1, and at this point we know that we don't need to keep on checking any further, because they have met and even they have exceeded. Left is not only equals to right, left is now greater than right at this point. So at this point we say that if left equals to right, we break. Why? Because left equals to right. But what this is signifying is that even though there is in some cases whereby we are dealing with palindrome of even length might eventually be greater than right. So we are not just going to put into consideration that left is equals to right. So there are some cases whereby left can be greater than right, and it's going to result in a valid palindrome, just like in the case of even palindromes like this. So all of these things, we're going to put it into account in our logic, and it's just so simple like that. For you understand, if you want to solve this problem now, let's quickly summarize the logic. So the logic, before we go into the code implementation, here's a quick reminder. If you are serious about landing a tech job, it's not just about learning skills, it's about being seen. Every like, every comment, every share you make on tech content help build your digital footprint. The more you engage, the more you show up in front of recruiters, hiring managers, and even employees at top tech companies. Visibility opens doors. Opportunities find people who are active, not silent. So don't just watch, engage, share, and let people know you are out here leveling up. This is how you get noticed in tech. Alright, let's go into the code implementation. Def valid palindrome. So we are calling the function valid palindrome, and it's going to be taken in a string. The string that I want to check for if it is a valid palindrome. So I will be returning a boolean value, either true or false. So now, like we said, we are going to be defining our left and right pointers, so to be the two extremes, so that we can check if the character at the left and right are the same. And while left is less than right, I hope you understand why we have this condition here. It's just to ensure, because at the point whereby left and right get to meet each other, they become equal, or at the point whereby left become greater than right, we know we need to exit the loop, because that's the end of the loop. So while left is less than right, we are going to be having this condition that while left is less than right, and s of left dot is unknown. So and not, well, having this condition here is that in a situation whereby the pointer left is not lying on a alphanumeric attribute, proper object, that is not referencing a alphanumeric object, probably whenever it's referencing a plus or a minus, or you understand, a non-alphanumeric elements or character, we are going to be increasing our left by 1. You understand? So that's what the why not, that is, if it is not alphanumeric, we increase by 1, and we keep doing that until it becomes alphanumeric. So same thing apply to right. And why we are putting this condition first, this left is less than right, is because we don't want it to pass. You understand? There's no point if left become greater than right. So we have to place this point that while left is still less than right, because we already have a condition right here that while left, so if at all left become greater than right, there's no point in checking if it is alphanumeric or not. We need to exit immediately. You understand? So that's why I'm placing that condition. And right dot is unknown. So if right pointer is pointing at a different element than a alphanumeric element, so we also need to keep moving and shifting it to the right until it focuses on an alphanumeric element. So if s of left is not equal to s of right, what we do is that we return false. So if after focusing on the next possible alphanumeric elements, and after focusing it's now realized that they are not equal, definitely we need to return false. You understand? So and now we just keep looping like that, and at the end of the day we return true. So meaning that if it could loop out successfully without returning false, definitely is gonna return true. So let's glance through it again. While left is less than right, and while left, so yeah, this is a check, and this is a check, and this is another check here to check if they are not equal. So one thing we need to do again is we have to now increment. Don't forget, we need to increment so that we can be sure that left and right are changing, they are approaching each other, because that's the only way we can exit out of the loop. So you understand, place your left and right at the two extremes, try to check if they reference the same elements, and if they do, then shift the left by one to the right, shift the right by one to the left to process the other element, and return true if we could break out of the loop without meeting a condition, this particular condition where the left pointer and the right pointer are pointing to different characters. So if we can exit the loop without returning false, then definitely we can return true. That means there is a valid palindrome. So print value, let's try print it out now of s. Well, I love writing, but I think this is not a really big problem, so that's why I think I forgot to write it. So but on a normal day I prefer to write my this thing. So let's run it now. Alright guys, so it's returned true. So, and that's just what it takes to solve this problem. So we are gonna be solving it now in JavaScript. Now this is the JavaScript code implementation. So it's so easy to write it in any language actually, not only JavaScript and Python, once you understand the logic. And if you look at this code, it is exactly just the way we write the Python code, and exactly by logic that we described earlier. So we see in our function we define our left and right to be the two extremes, and what we do is that we place a condition that while left is less than right, so as much and as far as left remains less than right, we haven't gotten to the end of the loop. So and what we want to do is that we want to first look if left is placed on the right character, which is the alphanumeric character. So we want to make sure that once it is not on the alphanumeric character, that's what this not is alphanumeric means. It will keep shifting it forward until it lay on the alphanumeric character, and similarly now this one too will keep shifting it until the right lays on the right alphanumeric character. So and after doing that, it's gonna check if they are distinct, if they are if the particular alphanumeric character at the left and right, if they are the same. So if they are not the same, we return false. If they are the same, we keep on increasing our left and right, you understand, toward the right and toward the left, pushing them inward to process other characters. And if it can go on and on and on like that, and it exits the loop due to the fact that left now eventually become greater than or equals to right, definitely we are going to be returning true, because that means it is a valid palindrome. So but in a situation whereby it returns false, definitely it is not a valid palindrome. So and these are just some use cases now that we write a function here, so an helper function that will help us to test if it is alphanumeric, A to Z and O to 9. So and we have this. So when we run it, it's definitely going to run. So this is all you need to understand this problem, and this is the solution. So don't forget about what I told you concerning sharing and engaging. Do well to share, do well to engage. The market is quite competitive now, and CV, resume, and skill sets alone won't do it. You really need to be visible. There are thousands and millions of people, even different platforms actually do not send what you shared and what you comment, and your engagement are not limited to your friends or followers or connections. They go outside, they go far beyond what you could think. So that's by sharing tech content and tech posts like this can really get you very, very closer to nailing your tech and landing that tech job. So alright, stay safe, and I wish you the best.